Hi everyone. Today we are going to discuss about some RCS and some of the post processing of the RCS data. So if you see over here, I have a uh, I have a metallic sheet. It's a perfect E sheet, and then there is a radiation box around it. And over here you can see an incident wave coming in this particular angle, which is 45-degree and hitting here and reflecting back. So this is what I wanted to see, how the wave is going to hit, how to see the result, how to interpret data, many other things. So we'll see today uh, how to see the RCS post processing. I hope you can understand from this data which angle this is going to incident. This is going to incident from theta 45-degree. So I can also say I want to see from 0 to 45-degree every two angle. Okay, so in this case we are going to discuss only in particular case 45-degree step the step of 0, and this determines which polarization you want. You want in vertical polarization, you put theta equal to 1. If you want horizontal polarization, you put phi equal to 1, and that depends on the electric field direction. So plane wave, this is a TEM wave which will have a direction of propagation, which is the K. You can see the wave is hitting in this direction, and the electric fields are orienting in the 90-degree orthogonal to that. So the magnetic field will be in another orthogonal plane. So that's what TEM stands for. So what you need to do is set up a solution frequency at 5 gigahertz, running the simulation. There is no much settings you need to do. Just run the analysis. I think I already ran the simulation. Now what you will see is we can plot the RCS of this particular thing. You can plot monostatic RCS or bistatic RCS. So today I'm going to discuss about bistatic RCS. So over here you can go to radiation pattern. Here you can see bistatic RCS, and you can put what I can say. Let's plot it in 3D. Oops, this is 2D pattern. So let's go with the 3D polar plot. Mm, Select by static RCS DB new report. So you will see that the RCS is high, which is in this direction. So even though wave is hitting in this plane, but all the rays are hitting towards the this direction, and whatever the field which is not hitting the plane, it will goes to the back side also. So RCS you will see in the two direction. Okay, so how I can see more clearly about RCS? So I'm going to select this plane which I would like to see. So I selected this particular plane which is YZ, and the wave is hitting in this direction. Right click, go to plot fields, electric field, mag E, just plot for a 0 dB. So whatever you're going to see here, which is the electric field, and it looks something not clear. We'll see before starting to post processing what is it mean by RCS data. So if I go here, the RCS stands for uh, yeah. So the sigma is RCS, which is equal to 4 pi r square, which is independent in terms of far field quantity. So it's just nothing but E scattered square power divided by incident square. So incident wave is nothing but the 1 volt per meter strength wave. And what is the scattered wave? It's just a ratio of scattered divided by incident power. So what quantity you're going to see over here is you have option to see the total field, incident field, or scattered field. So let's first see the incident field. So you can see the incident field here. So here you can see the incident field. Let's animate this. I'm going to animate this one, delete it. So I want to see from 0 to 350 degree. So full phase of a sinusoidal degree with every 10-degree resolution. So 35. So you will see the incident wave is coming in 45 degree. So in incident wave it will not count the structure which is over here. Let's leave it, and you can see the scattered power. So whatever you are seeing in the field view, it depends on these quantities. So this is nothing but the scattered power, which you can see which is radiating towards uh, so same phase. So you can see the field is radiating in this direction, and there are some field which is going in the backside direction also. Okay, so if I see the total field, which is the incident plus scattered, so I'm going to animate it. So you can see here the wave is coming here and hitting and going in this direction. So it's clearly should tell you how the wave is going to hit you, how the hit the structure and reflecting back. Now what we are going to see is I'm going to make this as a unticked plot visibility, so it won't be visible here. Now what we are going to see is I wanted to see the field which is coming the outside area of this particular 3D. So the field is available only inside this volume. So if I wanted to see the field which is outside this volume, it's possible only in 2020 R1 version of HFSS. So what you need to do is I'm just show you the steps. Create a coordinate which is equal to your global coordinate. What you need to do is you need to change here to Euler angle and change theta to 90. Okay, and you can see the xy coordinates are in this plane. Okay, now you need to make sure your xy planes are which is in the plane which you are interested to see the field propagation. Now what you need to do is you right click on the sphere, radiation sphere. So after that what you need to do is select the coordinate which we have created now, then insert the length. Let's see, we want to see the 10 centimeter by 10 centimeter in xy plane with respect to relative coordinate system 1. So I will put 301 points. This will be 301 points. Click OK. So after that you will be able to see an option called an near field report. Go to rectangular contour plot, and over here you can see that UV plane is selected, and you can see all these coordinates which is from -50 to +50 for U and V direction. Here you can see the near field theta phi, whatever the quantity you wanted to see, dB, and select this rectangular which is this property. Click OK. It may take time to post process it. So after that you will get this kind of a plot. Here doesn't show you clear idea about what's happening. So what you need to do is double click over here, you will get this window, and in the contour plot you can change to fringe and click apply. So you will see something like this. It's not looks good for me. And if I do a plot media, yeah, now this is looks good. Okay, what you're going to see here is you probably need to change the scale of this guy. Go here under the auto limit, specify the limits, put to 0 to let's say 25. Okay, still looks little. I'm just putting 15. Okay, so if I right click and show modular window, you will be able to see this is overlay on this. So which is something similar to the field which is coming here and going back, which the exactly what you're going to see here. The radiation pattern. Oops. Over here for field radiation pattern by static in dB take elevation. So out of this you can neglect this guy, which is 90. We actually want to see something this green color, and that's what over here. Now we are going to see is how to do the same problem in IE solver. What you need to do is take a copy of this, paste it over here, because IE doesn't need a radiation boundary. It's actually solving the surface current, and surface current on a vacuum or air boundary is 0. So it doesn't need to solve anything on the open, doesn't require radiation boundary. That's what I would say. And now I didn't change anything. Same excitation, so you looks odd. Yeah, this is what it actually do. So it's coming in the 45-degree elevation, same plane. What you need to do is you have a perfect sheet. You need to tell to HFSS solve this geometry with the IE region, PO region, SPR plus region, whatever it may be. Let's put IE region. Click OK. Now no setting change, and if you want to see the settings, so under the hybrid you can see different solver settings, ACA or MLFM settings you can do, otherwise you can put auto, depends on the electrical size of this one. So it will automatically find out what will be the best solver for that. Run it. So I already solved this problem here in the design one. You can see I think it's already plotted here. Okay, so here you can see the IE region, which is metallic IE, and there is a plane below. And same thing, you can see a coordinate is created here, and with a near field sheet you can see this saying quantity. Right click, show in modular window. So you will see same pattern is repeating for IE also. So that is indicating the accuracy of this two solver. Either you solve with FEM or with IE, you will end up with the same kind of a result. And you can even try with different solvers, like right click. You can ask HFS solve with the IE region or PO region, SPR plus region. This 3 region is possible, and you can do a lot with the RCS post processing. Thanks for your time.